its giant siblings, Mercury possesses a modest size, a fragile atmosphere, and a surface heavily scarred by impacts. Since its discovery by spacecraft, Mercury has revealed intriguing clues about its formation and evolution. Among the planets in the solar system, Mercury has the most unfortunate fate. With a diameter of only about 4,880 kilometers and over 4.5 billion years of existence, it has been continuously scorched by the sun's heat. This planet is on average only about 58 million kilometers from the sun. Mercury's orbit is a very narrow ellipse, with a semi-major axis of 70 million kilometers and a semi-minor axis of only 46 million kilometers. S orbital velocity is very high due to the sun. The extremely harsh environment and ancient surface of Mercury are far different from Earth's. Apart from 3 flybys by Mariner 10 in 1974 and 1975, which passed Mercury's surface at a distance of 756 kilometers, becoming the first successful probe to approach this planet. Additionally, no other NASA satellite survived to send signals home. Until March 2011 that NASA Observations from Mariner 10 showed that Mercury's surface has a very thin atmosphere composed mainly of helium. Images of Mercury's surface sent back by MESSENGER revealed countless craters. Although Mercury appears similar to the Moon on the outside, its surface environment is extremely harsh. The enormous tidal forces from the Sun's gravity cause Mercury to rotate extremely slowly. According to the latest reports, during one orbit around the Sun, Mercury only rotates 3 times on its axis. The side of the planet facing the Sun reaches temperatures up to 430 degrees Celsius, while the dark side drops to minus 170 degrees. Its core is also very special. Contrary to its small exterior, Mercury possesses a huge core compared to its mantle, while the crust is extremely thin. Its solid inner core is about 2,000 kilometers wide, nearly the size of Earth. This core makes up about half of Mercury's entire core, which is about 4,000 kilometers wide. Its diameter, the metallic core is believed to occupy nearly 85% of the planet. This anomaly has long been one of the most intriguing mysteries about Mercury. Mercury's peculiarity can be explained as follows. It was once as large as Venus or Earth, but due to its proximity, the Sun gradually blew away its surface layers. But there are other hypotheses suggesting that Mercury collided with some external force, leading to the stripping of its crust. Or continuous meteorite impacts over billions of years have significantly eroded Mercury's surface. MESSENGER's survey of Mercury includes using gamma-ray and X-ray spectrometers to analyze its surface composition. The main elements scientists are searching for are potassium and thorium. Both of these elements are abundant in the solar system, but they are also highly volatile and can only exist under certain conditions. Temperature is one of the factors that makes potassium and thorium most volatile. Both the heat and meteorite erosion hypotheses are based on earlier predictions that Mercury once had a surface temperature of up to 3,200 degrees Celsius. At this temperature, potassium and thorium would evaporate, and uranium would also be incinerated. However, MESSENGER refuted this. The ratios of these elements on Mercury are very similar to most other planets like Venus, Earth, and especially Mars. These volatile elements were separated from the surface, leading scientists to another hypothesis. Elemental dispersion caused Mercury's surface to erode. Scientists studied data from gamma-ray and X-ray spectrometers, suggesting that this surface erosion originated from volcanoes erupting volatile materials onto the surface. Over time, they evaporated and created enormous craters that satellites can observe from space. But weaker, only about 1.1% of Earth. Earth's magnetic field also has 2 poles, except that Mercury. Its magnetic pole is only 3 degrees off from the geographic axis, similar to Earth's magnetic field tilted 11 degrees. Measurements from Mariner 10 and Messenger show that the strength and shape of the magnetic field are stable. Mercury's magnetic field is strong enough to deflect solar wind around the planet, creating a magnetosphere. The planet's magnetosphere, although small enough to fit inside Earth, is strong enough to trap solar wind. This contributes to the space weathering process on Mercury's surface. When solar wind flows through Mercury's magnetic field, these interconnected magnetic fields are carried along and twisted, forming vortex-like structures. S magnetic shield, through which solar wind can penetrate and directly affect Mercury. Recent observations by Mariner have detected low-energy plasma flows from the magnetosphere on the planet's dark side. S magnetic tail, implying Mercury. The discovery of volcanic activity on Mercury, especially in the northern hemisphere, has truly challenged previous assumptions about the planet. This indicates that Mercury was geologically active for a longer period than previously thought. These new findings are making researchers very excited, especially in deciphering the planet's formation process. Nevertheless, more in-depth research is still needed for us to reach a final conclusion. Everything remains just a hypothesis, and if they're all wrong, we must find a backup hypothesis. This is a common occurrence in science. An old theory collapses, and it's not certain that a new theory can replace it. This does not mean we have failed, but rather a new step in the journey of seeking knowledge. Studying and researching Mercury truly faces many challenges because the planet is too close to the Sun. Probes indeed require tremendous effort to resist the gravitational pull from the central star as they approach Mercury. That means the spacecraft needs to consume an enormous amount of fuel to avoid being pulled into the Sun, a tragic outcome. Despite the immense challenges, NASA has excellently completed 2 historic missions, bringing spacecraft to approach Mercury at an unprecedented close distance to map this mysterious planet in detail. Thank you for watching the video.